In this video, we're going to talk about the acid-base properties of salts. And of course, salt meaning any ionic compound. So for example, this is an image out of the textbook, and it shows that when I dissolve ammonium chloride into water, I don't get a pH of 7. I get a pH of 4.55, which is acidic. If I dissolve sodium chloride into water, I do get a neutral pH of 7.0. And if I dissolve sodium carbonate into water, I don't get a pH of 7 or 4.55. I get a pH of 10.94, which is basic. And so these are the images. Okay. So why is it that dissolving different compounds into water does not, or different salts in particular, does not give me always the same pH? So, and how do you predict that? So basically, when I have a salt of a strong acid and a strong base, I get the neutral, which was the sodium chloride. If I get a salt of a strong base and a weak acid, then it's basic, and that was the sodium carbonate. If I get a salt of a weak base and a strong acid, it's acidic. What does that mean? Okay, so I took the example of ammonium chloride in the last example. Here's the image. It was 4.55 and considered to be acidic. So whenever I dissolve ammonium chloride in water, it breaks up into the ions of ammonium plus chloride. Now the ammonium ion is going to attach itself to the hydroxide from the water to form ammonium hydroxide, and that is considered to be a weak base. The chloride ion is going to attach itself to the hydrogen from the water molecule and form HCl, which is considered to be a strong acid. So the weak base plus a strong acid gives me an acidic, okay? Or the strong always wins out. So if I have strong versus strong, they cancel each other out, it's neutral. When I have strong base and a weak acid, the strong beats out, and so it's basic. The weak base and the strong acid, it's acidic. And the last one is when I have both a weak base and a weak acid, it depends on the strength of Ka versus Kb. If Ka is larger, then it's an acidic. If it's Kb, it's basic. I'm not going to give you any of these. I'm going to focus on giving you the first three there. Okay? So let's do an example of that. So you'll notice that these are all aqueous, means they've already dissolved in water. And so when I do this, I think of K. And since K forms a cation, it's going to associate itself with OH there. And then chloride is a negative, so it's going to associate itself with a hydrogen. Okay, so it has to be negative opposite charges, so the cation goes with OH, the anion goes with H+. And now look at this, okay? Potassium hydroxide, you have to know your strong acids and strong bases, is a strong base. Hydrochloric acid is a strong acid. And so therefore strong and strong means that this is going to be neutral. Okay? I suggest that you pause the video and try to do the next one on your own and then come back for the answer. For ammonium nitrate, again, I have NH4. NH4 is a cation, so it's going to associate itself with a hydroxide. And I have NO3, which is a negative, and so it's going to associate itself with a positive. And I come down, and NH4OH is a weak base. That was in the example I just gave in the previous slide. The nitric acid is a strong acid, and so this is acidic. Okay. And I tend to write these things such that the cation's always first and the anion's always second, so therefore it's the base is first and the acid second. If you always want to do it that way, that's fine. It doesn't have to be done that way. So I have sodium, which is a plus, and it associates itself with OH minus. I have C2H3O2, which is acetate, so it becomes acetic acid. And so the sodium hydroxide is a strong base. Acetic acid is a weak acid. So strong beats out the weak, so therefore this one is basic. Okay, again, I suggest pausing and then coming back to get the answer. The last example is aluminum chloride. So aluminum is a 3+ charge. So OH. For this exercise, you don't have to worry about that. It actually becomes AlOH3. But again, it doesn't really matter. What I want to look at is aluminum hydroxide. So in reality, this is AlOH3. I have chloride minus and H plus. And so to balance it, it's 3. But again, that doesn't matter as long as you know it's aluminum hydroxide. That's all I care about. Aluminum hydroxide is not one of the strong bases, so therefore it must be a weak base. And that's basically what I do. It's process elimination. Hydrochloric acid is a strong acid. So I have weak and strong, so therefore this one is acidic. Okay? And that is the end of this video.